Friends, welcome to the tutorial series on Basic Electrical Engineering Made Simple. In this tutorial, we shall study circuit concepts on Ohm's Law, power and energy. Friends, in the process, we shall see what is an electric circuit, what are the active and passive circuit elements, and later we shall define Ohm's law and its applications and also its limitations. And another very interesting concept is the graphical representation of Ohm's law. Later, of course, we will discuss about power and energy based on the Ohm's law that we have learned. Friends, first we shall see what is an electric circuit. An electric circuit is a combination of active and passive circuit elements connected in certain configuration. Active elements, can deliver power or energy. Friends, here are some examples of the active circuit elements. The first one is the DC generator, and its symbolic representation is shown here. The next one is the battery, and its symbolic representation is shown here. The third one is the AC generator, and its symbolic representation is shown here. Friends, now let us see what are the passive circuit elements. The passive circuit elements are those which can only receive power or energy. You know that the energy received is absorbed and is converted into heat, light, or it can be stored in the form of electromagnetic or electrostatic field. Friends, here are some examples of the passive circuit elements. The first one, if we take the resistance, here you see an electric iron and its element is a resistance. If you consider the incandescent lamp, you find that the filament of an incandescent lamp also is the resistance. And you see that the energy received by the iron is converted into heat and the energy received by the incandescent lamp is converted into light. Friends, here are another very important two circuit elements. One is called as inductance. It stores the energy received by it in the form of an electromagnetic field. And another element is a capacitance. It stores the energy received by it in the form of an electrostatic field. But in this tutorial, we shall take up only resistance and the inductance and the capacitance we shall study in detail in the subsequent tutorials. Friends, Ohm's law states that the current flowing through the circuit element, that is resistance, is directly proportional to the voltage applied across it, provided the temperature remains constant. Dr. Ohm inserted this phrase that the temperature remains constant because the resistance of the material depends on the temperature. And the materials whose resistance increases with the increase in temperature, they are called as the materials of positive temperature coefficient. For example, copper, aluminium, and silver. Similarly, materials whose resistance decreases with the increase in temperature, such materials are called as the materials of negative temperature coefficient. And for example, carbon, silicon, and germanium. So, according to Ohm's law, the Ohm's law is applicable when the resistance of the circuit element is constant. Friends, let us study the Ohm's law by taking a simple circuit as shown. In this circuit, we have connected a source of V volts across a resistance of R ohm. And we know the polarity of the source of V volts. A is positive, B is negative. It means C is positive, D is negative. We also know that the source will deliver power if the current flows away from the positive terminal of the source. It means current in this circuit flows in the clockwise direction. Let the current be I amperes. Now, you see that the current of I amperes will flow from C to D. What does this mean? It means that the current in the passive element flows from a higher potential point to a lower potential point as shown. This is very important concept that you have to understand. Now, according to Ohm's law, I is proportional to V, and this equation we can write it as I is equal to V divided by R. Now you note that the proportionality constant R, which is a resistance, is taken in the denominator. Why? Because the current opposes the property of resistance, and hence R is in the denominator. And using this I is equal to V divided by R, you know we can get three equations where R is equal to V divided by I and V is equal to I into R. Friends, Ohm's law can be represented in graphical form, and this concept is very important, friends. And you know, according to Ohm's law, I is proportional to V. It means any two quantities which are proportional to each other can be represented in the form of a straight line on the Cartesian coordinates. So let us see how we can represent Ohm's law in graphical form. Friends, now let us see how Ohm's law can be represented in the graphical form. For that, let us take the Cartesian coordinates in the first quadrant and represent voltage V volts along the x-axis and the current of I amperes along the y-axis. Now, to understand the graphical representation, let us take a resistance of 0.5 ohm. You know, 0.5 ohm is equal to 1 volt divided by 2 amperes. Now, if I ask you to represent this point on the Cartesian coordinates, you know it is 1 volt divided by 2 amperes. You get this point which should be on the line that we are representing. Now, if you join this point and the origin and draw a line, that should represent a resistance of 0.5 ohm. Now, if I ask you what is the slope of this line, you know slope is dy by dx. dy is 2 and dx is 1, so the slope of this line is 2. But have we taken 2 ohms? No. The resistance we have taken is 0.5 ohm. What does this mean? It means that the reciprocal slope of the line that we have represented represents the resistance that we have taken. That is an important concept that you have to understand. Now, because the relation is a straight line, the slope will remain same at all the points on this line. And if I ask you, what is the resistance at origin? If we say it is 0, it is wrong. Because when we take the slope of the line, we take the small change in y, that is dy, and a small change in dx, and because dy and dx are very small changes, the resistance at the origin also is equal to 0.5 ohm. This you have to understand. Friends, let us extend the discussion on graphical representation of Ohm's law. If you recall, we have represented the Ohm's law in the previous discussion only in the first quadrant, for which we took this circuit wherein the polarity of A is positive here, polarity of B is negative, and the current is in the clockwise direction. Now, let us reverse the polarity such that A is negative and B is positive, and the current flow is in the anti-clockwise direction. If we do so, the resistance line which was in the first quadrant can very easily be extended in the third quadrant, because R is equal to -1 divided by -2, which again will remain as 0.5 ohm. What does this mean? This means that the resistance line is true in the first quadrant and in the third quadrant also. Another very important concept is the resistance line is passing through 0. These are the two important concepts that you have to remember, so that some more interesting facts can be brought out in the next discussion. Now let me bring out some more interesting facts on representation of Ohm's law in the graphical form. In the previous discussion, we have drawn a resistance line of 0.5 ohm which passes from the first quadrant through the origin to the third quadrant. Now we shall draw another resistance line which is of 0.25 ohm. You know 0.25 ohm is 1 volt divided by 4 ampere, and you get this point which could be on the resistance line. So if you join this point and the origin and draw a line from the first quadrant to the third quadrant, you get a resistance line of 0.25 ohm. Now we shall see what will happen if we rotate the resistance line that we have drawn towards either the y-axis or towards the x-axis. Now, in the first case, if we rotate the resistance line about the origin towards the y-axis, you find that the resistance goes on decreasing. In this particular case, the resistance has decreased from 0.5 ohm to 0.25 ohm. Similarly, if the line is rotated about the origin towards the x-axis, its value goes on increasing. Now, if I ask you, what is the resistance of the line which is lying along the y-axis, your answer should be 0. Because if you observe this line, the voltage here is 0 and current is finite, and there is a concept which we call it as a short circuit concept. A 0 voltage and a finite current represents a short circuit. It means if the resistance is short circuited, its value will be 0. Similarly, if I ask you what is the value of the resistance line which is lying along the x-axis, if you observe this, there is a 0 current and a finite voltage, which means there is a concept which says that a 0 current and a finite voltage represents open circuit, and if the resistance is open, its resistance ideally could be infinite. Therefore, a resistance line which is lying along the x-axis can be called as a resistance line of infinite resistance. Hope you understood this concept very clearly. Friends, next we shall see the applications of Ohm's law. The conventional domestic appliances like fan, regulators, electric iron and electric heater are the examples where the Ohm's law is applied. In voltage divider circuit, this law is used to divide the source voltage across the output resistance. In electric and electronic circuits, there are many purposes where the intentional voltage drop is required, that you know. So, to supply the specific voltage across different electronic instruments, this Ohm's law is used. In many DC ammeter and other DC measuring instruments, shunt is used to divert the current. Here also the Ohm's law is used. Friends, here you find some domestic appliances, voltage divider circuits, and ammeter and voltmeter shunts, and many electronic instruments where the Ohm's law is applied. Now, let us see the limitations of Ohm's law. Ohm's law cannot be applied to unilateral devices and networks. Also, Ohm's law is not applicable for nonlinear circuit elements. We shall see more details in the next discussion. First, let us take unilateral devices. A unilateral network has unilateral elements like diode and transistors, which do not have the same phi relations for both directions of current. You see that in the case of a diode, the relation between V and I is non-linear during this region in the forward direction and nonlinear in this region in the reverse direction. Hence, Ohm's law cannot be applied in these regions. Next, let's consider the transistor. If you look at the transistor characteristics, the characteristics is nonlinear in this part of the region and hence Ohm's law cannot be applied in this region. Friends, next we shall consider the nonlinear element like thyristor and the electric arc. In these nonlinear elements also, current is not exactly proportional to the voltage applied across it. In all the region of the characteristics, we shall see the details in the next discussion. First, let us consider the characteristics of thyristor. You see that the thyristor characteristics is nonlinear in this region of the characteristics and hence the Ohm's law cannot be applied in these regions. Next, if you consider the characteristics of the arc, you find that the fault current is completely non-linear. This is because the arc resistance varies non-linearly and hence Ohm's law cannot be applied in this case also. Friends, next we shall discuss about the electrical power and energy. We know electrical power is defined as the work done per unit time, but the work done is equal to V into I into T. Unit of work done is joule or it is watt second. Higher unit of energy is watt hour. Still higher unit is kilowatt hour, and 1 kilowatt hour is equal to 1000 watt hours, and it is called as the unit of electrical energy. Friends, we know electrical power is defined as the work done per unit time, and work done is V into I into T divided by the time, from which we get the electrical power P is equal to V into I watts. Unit of power is watt and higher unit is kilowatt, and 1 kilowatt is equal to 1000 watts. Smaller unit is milliwatt and 1 milliwatt is equal to 10 to the power of minus 3 watts. Now, we know the three forms of the Ohm's law, and by substituting in suitable equations, we get P is equal to I squared R watts and P also is equal to V square divided by R watts. From the equation of power, we can easily get resistance R is equal to P divided by I squared ohm, and R also is equal to V squared divided by P ohm. That is simple. Similarly, we can get the equation for the current. I is equal to square root of P divided by R amperes, and phi is equal to square root of P into R volts. Friends, let me summarize and list the conclusions. The first one, Ohm's law relates the voltage across the circuit element and current through it. It states that the current through the resistance is proportional to the voltage applied across it, provided the temperature remains constant. Ohm's law can be represented graphically, and it is true in the first quadrant and in the third quadrant also. The VI relation in resistance element is a straight line passing through 0. If the resistance line is rotated about the origin towards y-axis, the resistance decreases. If it is rotated towards the x-axis, the resistance value increases. If the resistance line is along the y-axis, it represents zero resistance, and if it is along the x-axis, it represents infinite resistance. The power is defined as work done per unit time, and the unit of power is watt, kilowatt, or milliwatt. The unit of energy is watt second, watt hour, and kilowatt hour. Friends, I hope you liked this presentation on Ohm's law, power and energy. If you need any clarification, please forward your feedback and suggestions to my email. Thank you for watching this video.